All right, so this is the lesson for Science 24, 1.3, Chemistry at Home. All right, so if you looked at cupboards or cabinets in your house, you would find products that contain lots of chemicals for cleaning as well as for cooking. So for example, on the left-hand side, a lot of chemicals here. Some of them are for cleaning, like the Comet, the Javex, the Sunlight, but there's also things here for cooking as well, like the salt. Looks like there might be some vinegar here. So cleaning products contain chemicals that are going to break down dirt and grease and help make cleaning easier. And some cooking materials, like on the right, we have a lot of cooking materials like flour and yeast. They also contain chemicals that react when combined with other chemicals. And basically, these are called chemical reactions, which will help in the cooking process. So when we talk about a chemical reaction, it's a transformation that occurs when substances react. And one or more new substances is formed, and this new substance will have properties that are different from the original substance. Here, drain cleaners. When we talk about drain cleaners, I can't think of any, like Drano, that would be a drain cleaner. They contain a corrosive substance like sodium hydroxide, and sodium hydroxide is a base, and it's usually used for cleaning solutions like oven cleaners and drain cleaners. And bases like sodium hydroxide, they help clean clogged drains because they break down the proteins like skin cells and hair and animal fats, which is usually the problem in a drain problem, causing the clogged drains. And also heat is given off, which helps melt the grease in the drain as well. Here are some common chemicals and how they clean. Hydrochloric acid or steam irons, and basically it reacts with the lime, the scaly buildup, and it forms a soluble product. Acetone is the substance found in nail polish remover. It dissolves away nail polish, and then it can be wiped away easily. And methanol or wood alcohol is a paint solvent, and it will dissolve paint. This one here is an example of hydrogen peroxide, which is used to clean cuts or wounds. So when you pour hydrogen peroxide on a cut, it starts to foam. And the reason being is that hydrogen peroxide turns into water and oxygen, which is a chemical change. And then that foaming that happens helps remove the small particles that enter the skin and might cause an infection. So this chemical reaction will also kill bacteria that may enter the wound. Next are hazardous household product symbols, which are abbreviated to HHPS. So these are safety symbols that are placed on like household hazardous products to make sure that consumers are using them safely, storing them safely, and then disposing them safely. So on the left-hand side of this diagram, we have this first shape, the octagon, and it means danger. The diamond meaning warning, and then the triangle meaning caution. And then we have the symbols here: poisonous, flammable, explosive, and corrosive. Now keep in mind though that because of recent changes, the warning symbol is no longer used. Just the danger symbol and caution symbol is used. So what you'll see is the two shapes that are used now is just the octagon and the triangle. And the octagon shows that the warning refers to the content of the container. So whatever is inside the container is represented with the octagon, And the triangle shows the warning for the container itself, because some containers can't explode because they use a propellant that may explode when heated. So a warning label is now given regarding the container. So the triangle is for the container, and then the octagon is for whatever is inside the container. All right, so for example here, it's a spray adhesive, which HHPS symbols appear on the product. So we can see poisonous, and we also see flammable. But we also see this triangle here, which represents explosive. So that means that the contents inside the container are poisonous and flammable, and then the container itself is explosive. All right, next we go into chemistry and cooking. So bakers, chefs, people at home that cook use chemistry every day, measuring ingredients, applying thermal energy, and causing chemical and physical changes to matter. So, for example, yeast. Bakers use yeast to make bread. Yeast is a single-celled organism. It needs food, warmth, and moisture to live. So it converts its food, which is sugar and starch, into carbon dioxide and alcohol. And it's that carbon dioxide, the bubbles that we see when we're baking, that's what allows baked goods to rise. A mixture of vinegar and baking soda can also produce carbon dioxide gas, and sometimes bakers use that mixture as well to make baked goods rise. This is just from the textbook, an interesting fact here that some fruits like citrus fruits and rhubarb, they react with kitchen utensils that are made of aluminum. The acid in those fruits, they react with the aluminum in utensils and will start producing a hydrogen gas, and then this reaction will cause the utensils to become corroded, and they're no longer useful. So many utensils in the kitchen are made of stainless steel. We had talked about stainless steel in a previous lesson as well. The stainless steel will not react with the acid. Another fact is the aluminum soft drink cans. They do not react with the acid in the soft drink because the aluminum has been coated with a plastic polymer, and that keeps the pop from reacting with the aluminum because it doesn't directly contact the aluminum because it has that plastic coating. All right, so there's a couple videos here to watch. The first one is chemistry of cookies. It kind of goes through all the changes that happen when baking cookies. And the second video goes into chemical changes as well with, for example, cooking and baking. All right, here on the last slide, there is a recipe here. In the textbook, it's called Investigation 1A, and it is a recipe for chocolate chip cookies. It's just written in a method that chemists would have used. So instead of flour, they're saying it's a mixture of 75% starch, 25% protein. Instead of salt, they're using sodium chloride. Instead of sugar, they're calling it sucrose. So it is interesting to see how all the ingredients are actually chemicals. All right, and then on page 15 is the check your understanding for 1.3, numbers 1 to 3.